So this is the assignment which we have. It's basically a base plate with anchor bolts, and that's what the exercise will be. The base plate is different from normal base plates in the sense that if we zoom in over here, you will see that it's got two levels over there to make it stronger against bending. So the base plate itself over here is drawn out over here. It's 700 by 700 base plate, and then at a height of 195 millimeters above the bottom of the base plate, you have another plate on both sides, and these plates are called the top plates. They're given, their dimensions are given over here. And the column itself, which is an HEA 300, the flanges have been cut out because these plates over here, the flange plates, they are basically extending the flanges into the base plate as shown. And then the details, of course, of the anchor bolts themselves, what the diameter is and what the bending. These are J-type anchor bolts. So what the diameter will be, what the radius will be, how much the extension will be, how many plate washers we will need at the top, and a nut, and those kinds of information, and the length to which it extends below the base plate. All that information is given, and we need to model this in COMOSYS. So let's begin by creating the column and the base plate, which, like I said, is 700 by 700, and the thickness of the base plate is given as 20 millimeters. So we go to the model, we go to our column command, we enter a column over there, we change the section to HEA 300, that's fine. And then we just need to create a 700 by 700 plate over there. So we can go to the plate. It's because it's a rectangular or square plate. We can just hover over this center point, the grid point, say enter, say at R 700 by 700. And when we say enter, that plate will have been created. Now, although not given in the exercise itself, but typically the bottom of the column is actually the bottom of the base plate. So if I look at it from the side, the plate is entered as middle, which is not what we want. So I'll just select it and press Control W to bring it to that position. And since it's a 20 millimeter plate, all I need to do is just double click on the column and give a start offset of 20 as well, so that it's not clashing with the base plate anymore. Now let's get back to the drawing and focus on these flange plates, which are basically going to cut the flange of the column as well. And these plates are given as 700 by 400. Let's not worry about these chamfers at the moment. So 700 by 400 plate I want on both sides of the column. So I can go back in, choose my contour plate command. Just use these points over here because they're easily available. Don't worry about the location at this point. Press on enter, say DZ 400, go vertical, then cover over this point, enter DZ 400 once again, close the loop. We have the plate thickness was 15 millimeters, so we changed that like that. So it's 15 millimeters, and then we press Control W to make sure it's positioned like that. And then we need to move it in such a way that this outside face is the same as the outside face of the flange of the column. So we just move linear. We can select this corner, and we can select any point on the edge by keeping the Control key pressed. And since this is a movement in the Y direction, we only keep that part of the move like that. And then we can give these 2 points, this one and this one, chamfers of 200 by 200 as the requirement was, like that. And once we have that plate in place, what we can do is, if we turn on the all visible mode, we can click on that, say copy, say mirror, and we can select the midpoint of this base plate across to the midpoint on the other side and say run, and we will have the two plates on both sides of the column as shown. Now that we have those two plates in place, we can simply go to the edit menu and the cut command and choose the part cut. And what we need to do is cut the column with these plates. So we say part cut, we select the column, we select this plate, select the column again and select the other plate. And what we will have is, if I select the column and say show only, you will see that the column has been cut. The thickness of this, the flash thickness was 14 and our plate is 15, so it's just gone across one extra millimeter into the web of the column. So that was easily done, and we can now focus on the rest of the assignment. Now, I've just realized that in the assignment, if you zoom in, these flange plates are actually not flush to the outside. You see this little bump over there. They're actually flush from the inside of the flange. That doesn't really matter. It could be done both ways. So we'll just continue. The only difference that'll make it will be the width of these top plates over there. Instead of 204 millimeters, they'll probably be 205. Let's see. So let's continue with these plates now. The top plates. They're basically coming out of that flange plate all the way till the edge of the base plate and all the way across, because this length is 700 as well. So what we can do is you can go back to the model and we can go to our steel command, go to the plates. We can select this point and this point and this point, this one and this one, and we will get this plate. Let's see what the thickness of the plate is. The thickness of the plate is 20 millimeters. And if we zoom in, the top of this plate is 195 millimeters from the bottom of the base plate. So we can easily move that to that location. So first of all, let's change the thickness to 20 millimeters. And then remember this 195 from the bottom of the base plate. So for that, let's just select this plate. Let's double click to see the thickness. It's 20 millimeters, that's fine. Now we just say right click, move, and we know that the top needs to be 195 from the bottom. So we hover over this point and we press enter and we say DZ195 like that. And that basically requires us to have a net movement of 165. So if we just say move like that, we will see, and we can check actually the numbers. So the top of this one should be 195 from the bottom over there, which is exactly what we want. Now let's focus on these holes in the top plate, which are also going through the base plate as well, because the anchor bolts will be going through. So we'll just create these holes over there. They're 30 millimeter holes on both the top plate and the base plate. So for that, if you remember, this distance is given as 102. It's in the middle of the top plate, and that's only because this one is 204. And if you remember, we didn't model it flush. We modeled it flush with the outside, so our distance is 205. So what I'm going to do is I'm just going to make this 102 into 102.5 so that it's still in the middle. So keeping that in mind, this one is 102.5, 125 offset in this direction, and then basically 4 holes, the distance of 150 each. So if I go back to the model, I can go to my bolt command with auto coordinate system. I can select this one, I can select the base plate, I can select this plate over here, right click, and I can just select an origin over here first and give it an X direction just to start off. It's going to give an error because it's right at the edge. I'm okay with that. I'll physically take this bolt and move it linear. In the Y direction, I want it to be 102.5, and in the X direction, I want it to be 125. I don't want any Z movement. So I'll just move it like that. It's still giving an error because of this distance. It's not being able to find a bolt which is that long from the database. So I'll just double click on that and just tell it that this is not a bolt, it's just a hole. If I say that, you will see that the bolts immediately appear. Now all I need to do is go to the positions tab and give the 3 into 150, which was the distance between the holes, and there you go. And then one final thing, the holes were 30 millimeters despite the 20 millimeter anchor bolt. So we can give a bolt tolerance of 10 millimeters like that. So these are now aligned bolt holes for the anchor bolts. And all I need to do now is just select this plate actually. Because these holes are going through the base plate as well, I can just select this top plate, right click, say copy mirror. The mirroring plane is already defined as the middle. I'll just say run. And you see that the holes are also brought to the other side and even to the base plate, because these holes are going through both of them at the same time. Now let's focus on these stiffeners over here between the two top plate and the base plate. These 5 stiffeners on each side. They're drawn over here as well. Once again, the 204 will become 205, but the rest will be the same. And the chamfer is 25 millimeters. So and they're located at 50 millimeters from the edge, and then 150, 150, 150, 154 more copied, like shown on the drawing as well. So let's go in and they're 10 millimeter plates. So go back to the model, and what we can do is we can go to the plate command. We can just select these corner points because they're available without worrying about the exact location at this point, like that. This is a 10 millimeter plate. I'll just say 10. I'll give it a chamfer of whatever it was. I think it was 25 or something. We've got the chamfers inside, and then we know that the first plate is at a distance of 50, and then there are 4 more at 150. So I'll go back to the model, select the plate, right click, say move linear, reset this in the X direction. I'll say 50, like that. And then I need to copy them, 4 more copies at 150 each. Go back to the model, say copy linear, 150, 4 copies, like that. So we have them. We can give them a different color if we want. It's perhaps a better idea. Makes it easier to visually see. It's also a good idea to give them names sometimes when you're annotating drawings. It's better to have them with different names, but for the moment we'll just continue with what we have. We'll just select these plates, right click, say copy, mirror. The mirror plane is defined. We just say run, and we have the plates on the other side as well. Now let's get to the anchor bolts themselves. And if we come to the formwork menu on the right, inside the formwork menu there's a sub menu called embedded objects, and over here you will find the anchor bolt tool. And when you click on that, it actually asks for a point. So you can actually select a point and it's going to create an anchor bolt over there. But if you right click at this point, it can also ask you for a plate, and in which case it will find all the holes on that plate and create anchor bolts for each of the holes. So I've right clicked over there. I'm going to select the base plate, and when I do that, I immediately get my 8 anchor bolts. We'll of course modify them now, but I get my 8 anchor bolts, which I need to now play with because mine are obviously different. It's a 2-level base plate. These ones need to come out all the way to the top. There's certain distances given, etc. So we need to work with this. Now, if we double click on any one of these, they're all separate anchor bolts from each other. Each can be modified individually. If we double click on that, we see that there are 3 tabs: the figure tab, the geometry tab, and the presets tab. And in the figure tab, we have the type, and we can change. We've got several types. This is this J1, which is actually the one we want. In this case, is called the C type. But there is something called the H type, which looks a bit like that. Then there's something called the L type, which is a bit like that. There's something called the U type, which not really used in steel base plates, but can be used in other situations. There's the full simple, which has got a pipe around it to increase the adhesion. There's another one with end stiffeners as well. And then there's another one which is called half simple type, which has got a partial pipe. in there, half with stiffeners. Then it's got the simple type, which is basically just the normal typical anchor bolt which we usually have, and it's got the stiffened one as well. So several different types. We can come back to the C type. There's one. There are a few at the top as well. The headed type, and the threaded type, and different types over there. We want the C type at this point. But the thing is, where is it getting these this information from? So once I choose the type, if I come to the geometry type, geometry tab over here, I can choose the diameter of. So I can, let's say if I choose M20 like that, it changes the length as well. It changes some other parameters as well, like these bending radii, these lengths, how much it protrudes outwards. It's got assumptions on this is the grout under the base plate. It's got certain assumptions. You can change these. It's got an assumption on the thickness of the base plate. You can change those. You can change this number of how much it is protruding from the bottom of the grout, which is basically the top of the concrete, where the concrete will be poured, how much it needs to protrude out, and how much it goes in before it starts turning. All that information is given over there. But the thing is, when I change diameter, for example, if I go for an M30, for example, some things might change. The lengths might change. So M16 was shorter, if you remember. It's getting all this from a file, and this file is actually, if you go and click on the preferences folder, and you go to the company preferences folder, you can also have it in the local, but right now it's getting from there, I think. If you come down, anchor bars, anchor bolts, anchor bolt defaults. This is the file. If I double click on that, it's a text file which you can actually modify. So if you remember, it had all these types of headed. It had headed type. It had the threaded type. The pipe we are in our case, it was the C type. So it's got 6 C types already in that file. And for each type, there's the diameter, 16 millimeters, 20 millimeters, 24 millimeters, 27 millimeters, 30, 36. And for each one of these, you have these geometric attributes which it uses to actually create the lengths. But you can always go and modify those lengths from the tool itself. But you can also arrange this file or modify this file so that automatically it brings up what your company standards are. So if you want to do that, you can modify this file, you can add new types, you can add new diameters. And once you're satisfied with that, you can actually take this file, and like we've shown in the other exercises as well, which are related to setting up your environment, you can copy this file from your local folder to the related cloned environment folder as well. So all that is possible. But let's come to our particular case. So in our case, it's an M20 anchor bolt. It says Phi20J type anchor bolt. 4.6 is the material. And the total projection is 5 from the bottom of the base plate is 580 to the bottom of the anchor bolt. That's what's given, this 580. And this includes this bending radius of 70 millimeters from the bottom of the base plate, remember that. So 580 from the bottom of the base plate all the way down, including a 70 millimeter. So if you go back to the model, you will see that first of all, this distance is not given from the bottom of the base plate, it's given from the bottom of the grout. So right now, including the grout, the grout is 50. 50 plus 460 is to this point. That's 510 plus 70. So it is already 580. This 70 is the radius. You can change these numbers, but the defaults happen to be the same as our assignment. But we could, of course, increase these numbers or reduce these numbers. All we need to do is just count the grout distance, this distance after the grout, and then add to that this distance over here. The other requirement was 80 millimeters straight portion up and this 70 millimeters bending radius. Those are also according to the assignment. You can change this if you want, but in our case, we don't need to. This 80 is the same as well. We'll be working mostly on this area. So right now, if you notice, if I just close this, this anchor bolt is coming and basically ending at the base plate, whereas I wanted to actually go through to this other top plate as well, come out on the other side. And I know that, so let's see what my distances are showing. So I've got control over the bottom of from the bottom of the grout to the top of the anchor bolt. So let's assume since it's assuming a grout distance of 50, what I want is actually for it to come out. So how can you do this? Let's see. So this is assuming a 20 millimeter base plate. What if we make it assume let's go right click and say measure distance, and from here to here, this one is 195 from the bottom of the base plate to the top of the top plate. So what if I enter this distance to be 195, like that? If I do that and I say apply, you will see that these nuts and these washers and these washer plates, etc., they have all been moved to that point. The other thing I would want to modify is this, how much the anchor bolt itself protrudes above that. And for that, I would want, let's go back to the drawing, from the bottom of the base plate, it is given as 265. The bottom of the base plate, 265. So in our case, we'll need to add, because we have control from the bottom of from the grout. So if it's 265 from the bottom of the base plate, it needs to be 305, I guess, to the top. Let's see. Maybe this one needs to be 305, like that, or a little more. 315, was it? 300, let's see. Yeah. So that number will need to be modified as well to bring the anchor bolt out to the exact position which we want. Basically, you'll be playing with these numbers to move the tip of the anchor bolt itself, and these washers and nuts you can modify. You can move them around. You can actually not create a second nut if you want by entering some of these numbers to be 0, things like that. You can play around with this and get the result which you want. So after having done that, once you're okay with one of those, what you can do is you can select all of them, right click and say match elements, and then select the one which you have modified. And once you do that, then all your anchor bolts will be moved accordingly. Now, one thing we didn't do was maybe this one needs a hook angle, a different hook angle. Let's which one is that? The rotation, this one. So this one, if we call this 90, let's see what happens. So this is the one we want, that's fine. So what we can do is we can select these 4, right click and say match elements to this one, so that all point out. And the other 4 will probably be needed to make, we'll need to probably enter -90, so that they point in the other direction. And then we can just select the remaining 3, right click, say match elements to this one, and we will have our anchor bolts ready according to our assignment. Now, if we zoom in over here, we see that we've got 2 plate washers rather, one larger one and then one smaller one before the nuts start. We've got 2 nuts as well, but we've got 2 of these plate washers as well. So we have control, and the details are given over here. The bigger one has a size of 70. They also have the same holes because the anchor bolts are going through them as well. So the bigger one has, by bigger one I mean this bottom one has a size of 70 millimeters, if you remember from there, 35 plus 35, and the other one has a size of 40. And we do have control. If you go back to the model, double click on the anchor bolt, we do have control over that 70. So this is the size of that washer, and you also have control over the thickness of this washer. And then the other one, the smaller one on top of it, has got you have control over its width as well from there, and the thickness over there. And then you've got control over the size of the nuts, etc. which you can change. So you do have almost complete control over what you want. You can, like I said, you can read this information from the file, but that doesn't mean you're stuck with it. You can get the basic information about the M20 anchor bolt, and if in a particular case you want to modify it, you can still modify it from here as well. That will not change the file. That will just change that particular instance of the anchor bolt. So a very nice and quick way to create your anchor bolts inside base plates. It's generic because while you can create any combination as well. You can if you already have a plate with holes in it, then the better way to use it is to click on that, right click, instead of showing each individual hole, just show the plate. Or otherwise, if you got some holes through which you don't want anchor bolts there for other reasons, then you can individually show the holes as well. So quite easy to use and very generic as well. And like I said, many different types are supported, which is all backed by a file. So once you set up this file in your environment folder, you can very easily, quickly go about creating your base plates. Now, to be fair, there's a little shear key as well under the base plate, made of 4 individual plates. You can see it over here as well. I won't be showing that in this tutorial because those are just simple plates. You can always make them on your own. The basic idea for this tutorial was to actually mostly talk about the anchor bolts, because the plate commands you already might be familiar with, but to get you familiar with the anchor bolt tool. So I'll leave you to finish off the shear key, etc., and then that will finish the assignment.